Hello everyone and welcome to the Covidence Community Webinar for June 2023 entitled An Update on Machine Learning AI in Systematic Reviews. So I'm going to be your session facilitator today. My name is Julie Brown and I'm a Community Manager at Covidence based in New Zealand. And I'm also joined by Laura Meller, who's the Head of Community Support, who's based in the UK. A little bit of housekeeping before we begin. Today's session is being run in standard webinar mode. All webinar attendees will be muted, but you can ask us questions at any time by using the questions box, which you should see on the right-hand side of your screen. The session is recorded and everyone who's registered will receive a link to the recording by email within 24 hours of the webinar. Any slides that are shown will also be available on our knowledge base after the webinar. So here's the agenda for today's webinar. In a moment, we're going to hear about some of our own machine learning and AI initiatives from Alex Walton, who's a Senior Product Manager at Covidence. And then we have our panel discussion. So I'm going to hand over to Alex now, and then I'll introduce you to our panel. I'm just handing over to Alex now.
Awesome, thanks Julie, and I hope everyone can now see my screen. So to kick off the webinar tonight, just wanted to have a chat to everyone about some of the machine learning features that we currently have in Covidence, but also discuss a little bit about what's coming next in the Covidence product in terms of machine learning. So a little bit of background. I think it's obvious from the amount of attendees we have at tonight's webinar, but also from what's going on in the community, that we are hearing that machine learning is really taking off. We are seeing a rapid expansion in the development and use of machine learning, in particular large language models. And these models are becoming way more powerful and able to take in a lot of different variables to make decisions on, which allows it to have much more context in terms of what it's using to make those decisions and judgments, and then resulting in better outcomes or more accurate outcomes. And what we are seeing by this development is many products, especially in the systematic review domain, are doing increasingly more exploring of these possibilities that they can use machine learning for to support users completing tasks. In terms of Covidence, how we're using machine learning at the moment, it is to solve a challenge of the screening time being time consuming. So with this, we are seeing it being about roughly 33 person days on average to complete screening, which is a significant amount of time that's being spent during this stage. We are currently using machine learning to speed up screening while maintaining high methodological quality. So we want to ensure that we're using machine learning to get those benefits and improve the efficiency of the screening process, but we are acutely aware of the importance of quality of the output of reviews, and really approaching it in a safe manner to ensure that any of these offerings or solutions that we're releasing to the product are not going to impact the quality, but improve the efficiency of screening. Currently, this is 2 machine learning powered features that are in our product at the moment, being the RCT study tagging, so randomized controlled trials, and the most relevant sorting. To talk a little bit more about the randomized controlled trial study tagging a little bit more, first, essentially how this works is studies are automatically tagged when they're imported into Covidence based on whether or not they are a possible RCT or not an RCT. And this allows screening teams to identify clear exclusions faster, especially though in the scenario where you only want to do, or you only want to include studies that are an RCT study design. This currently is only available to medical and health science reviews based on how the model has been developed and trained. And it's worth calling out, we are fortunate tonight to have James Thomas on the call, and we've been working very closely with them, who developed the model that was endorsed by Cochrane as well. And it has been trained on a large portion of studies with a very good sensitivity of 99.5%. And we are seeing great adoption in our product of this already. So we have over 5,500 medical and health science reviews already using this feature on their actual real reviews. The second feature that we offer at the moment is most relevant sorting. So when you are in title and abstract screening, we do offer different sort options in our experience. But the one that we have set to default, and we get the vast majority of users adopting and using, is the most relevant option. So how we're doing this, we are also working with a active learning model developed by Epicenter. And what this does is predict studies inclusion likelihood based on previous decisions that the screening team has made. So as you go through screening and you either include or exclude studies, the model will start to understand trends in how you're making those decisions, and then we'll score the remaining studies for screening based on that. And on that score, we then use that to sort the list to show the ones that the model predicts are most relevant first. How we think this will help screening teams is it allows you to find all of those all of the relevant studies or potentially relevant studies much sooner in the review. So if we didn't have this sorting enabled, it would take a long time. You'll get various different potentially relevant studies popping up through the screening process at all stages throughout, whereas with this feature enabled, you should start to see more of those relevant studies earlier in screening, allowing you to move those through to later stages of the review sooner, hopefully cutting down that overall time to complete screening. We have been very careful with this solution, and essentially what we've decided to do is not display any of the scoring that the model is providing. And this really just makes sure that we are protecting from bias in the screening decisions. So we don't want to change or alter people's decision on these studies. So we have kept that behind the scenes, so it isn't coming into play in terms of when you're deciding if that study is relevant or not. So those are the two features we currently have in the product and are available. And it'd be worth calling out that the most relevant sorting is across every review. So any area of research or review type that you're doing in Covenants, that one is available for. So touching on what we're currently working on, we think there is much more opportunity in the space, especially with the development of models and where they're starting to progress to. And we're currently exploring automatically excluding irrelevant studies. So what we think we can do is by using PICO's inclusion criteria, we're looking at how we could use machine learning to automatically exclude a portion of irrelevant studies on import into Covenants before title and abstract screening is started. We have been doing some early validation around this and with the models. And we're feeling pretty confident that we can significantly reduce the studies requiring manual screening while ensuring that over 99% of relevant studies are kept in the review. And just wanted to touch on this 99% a little bit more. We have been doing a few surveys in the product and talking to our customers to really understand what the expectations are around these models around their performance and what people expect them to perform at before they are really used in their reviews. And 99% is where the community, or over 99% is where the community is expecting, and that's what we're setting our model to. And we are ensuring that we're collaborating with the community very closely throughout this design of this feature to make sure that it is appropriate for their use and what they would expect the model to be. So it's performing at the right level, it's doing things in the way that they would expect. In terms of this, we are using PICO's inclusion criteria in the product, which is something that will be coming very soon in terms of being able to collect that or provide that in the product and then view it in the product as well. And the model will use that to essentially understand and have a bit of context around what is actually supposed to be included in the review and what's not relevant to the review as well. We will be doing further validation on the model. We are essentially it's one thing that's really important to us is the safety of these models and making sure that we aren't impacting the quality of the systematic review in a negative way. We see the quality as being really, really important in here. We don't want to roll out any features in this space that is going to have any impact or negative impacts in that space. So we will be moving forward with doing further background validation behind the scenes and comparing it to manual screening decision to make sure the performance holds across a larger set of reviews. Then we'll be looking at how we can then roll that out further, looking at a beta program to start to get feedback from those that are comfortable using it. And then we'll explore where we can essentially go further with that and rolling it out more broadly if the beta community is comfortable with it and the feedback we get is really good. Just to summarize this, this approach will be reducing the number of irrelevant studies requiring manual screening relatively significantly. We will be vigorously testing, validating, and evaluating the model's performance to ensure that it meets the requirements and levels that the community expects. This feature will be aligned with PRISMA 2020, so we are looking at implementing it. So it is essentially going to fit into the process that PRISMA 2020 outlines. And we will make sure that this is very transparent and controllable by research teams. So they have control, they can see what the model is doing in terms of making decisions and what studies it's excluding, but also allow you to control it to either turn it off or override decisions to make sure that you are in full control of your review. A few things that this is not. This won't be generative AI, so it's not going to be coming up with things, developing things, or taking away kind of control in terms of what the research is on or your papers that are written outside of this. It won't be like asking a large language model. So for an example, ChatGPT, it's not going to be like just asking them a question and it's going to make a response based on its knowledge. We are using context that's provided to it specific about your review and the studies that are within it. And the last one, this is not going to be taking away from the control away from the reviewing team. And that's a critical thing for us, is that we want to make sure that the reviewing team is always in control, always has transparency over what the model will be doing, and can override it at any stage or look at what it's doing at any stage as well. So if you're interested, we already have, as part of that survey, opened up for people that might be interested in being involved in the beta program. And if you are interested in finding out more or keeping up to date about it or even being involved, if you scan the QR code, there's a short form there to complete. We'll keep you up to date with our advancements in this area. We'll also reach out to you to get feedback and also advice on the direction that we're going with new features, as well as potentially gaining access to early features in the Competence product as well. And that is everything I wanted to go through today. Thank you.
So thanks, Alex. That's great to hear about some of the exciting new features being developed by Covidence. I'd just like to thank those attendees who submitted questions in advance of this session, and that's really guided to the next part of our webinar. So having said that, I'd like to introduce you to the panelists who are going to discuss the role of machine learning and AI in systematic reviews. Firstly, we have Professor Gillian Elliott, who is the co-founder and CEO of Covidence and a leading innovator in evidence systems. He developed the living evidence model, which has been taken up around the world as an approach to keeping rigorous evidence up to date with the latest research. He's also founding director of the Australian Living Evidence Consortium and the Australian National COVID-19 Clinical Evidence Task Force. Our guest panelist is Professor James Thomas from University College London in the UK. James is a Professor of Social Research and Policy, the Principal Investigator of the Systematic Reviews Faculty for the Department of Health, and co-leader of the Cochrane Project Transform, which includes the use of machine learning to improve the efficiency of systematic reviews. And our third panelist is Alex Walton, who we've just heard from, a Senior Product Manager at Covidence. So I'm going to hand over to Gillian. If our panelists can switch on their cameras and microphones now, so that we can see you all.
Great. Yeah, thanks very much, Julian. Thanks everyone for joining today. We've got an amazing attendance, which I guess is an indication of the interest in this field. So we just wanted to have a discussion, a pretty informal discussion around machine learning and systematic review. So we've got some questions that were submitted before the webinar, and then for any of you that are online at the moment and you want to ask some questions, please submit them and we'll try and weave in some of those to the discussion as well. So I'm just going to kick off with a question for you, Alex, a kind of follow-up that we got. So how does Covidence ensure the output of the AI is correct?
Awesome. Thanks, Julian. So yeah, this is really important with really testing these models to ensure suitability. How we've been doing it currently, and it depends on the model, and I might let James speak to some of the ones that are in there at the moment, but for the current development that we're doing, we are using essentially the decisions that are being made by manual screeners through the process and comparing the model's results or responses to those of the manual screeners. And that's not impacting reviews at the moment. It's purely behind the scenes where we can pass in things, but we know what the manual screeners are expecting or wanting that study to be set to. And we're using that information to essentially guide what the expected output is of the model or where it should be going to help us then train and validate the models. And we are using essentially real data and real examples to not only validate but also train models. So we can essentially have that as a grounded truth in terms of what we're doing with these tests to make it as realistic as possible before we start to introduce it into the product.
Great, thanks. So James, your mission, should you choose to accept it, is to succinctly explain how one of these models works. So perhaps the active ranking or active sorting algorithm. Can you perhaps give us some explanation about how an algorithm such as that works?
Sure, succinctly, you say. Yeah, I think there are sort of some starting principles that it's worth bearing in mind when we're thinking about using machine learning for any purpose, but in this case, we're talking about systematic reviews. And that's that these things are not sort of magical and undecipherable to somebody who's not a computer scientist. We must sort of throw away what we know about statistics and what we know about inference when we start using these things. So Alex mentioned the RCT classifier, for example. The RCT classifier was based and built on a lot of data, and when presented with an input can tell you the likelihood that that piece of text, the titles and the abstracts, do or do not describe an RCT. Now it can do that because it's seen lots and lots of other data, about 20,000 plus randomized trials and around 260,000 non-randomized trials. So a very, very big data set. And it essentially learns the characteristics of what the report of an RCT looks like and what's the characteristics of an RCT doesn't look like based on that data set. So the reason I mentioned that we don't throw away what we know about inference and what we know about statistics from other parts of our lives is that the use of a machine learning model is just the same, really. If you've got a paper in the medical domain, which these records came from PubMed and Embase. So if of human trials, then this model will work well because you've got a question which is well represented in the data set that you've used for training. If you then say take an RCT from education and apply it to the RCT classifier, it will work up to a point, but it won't work quite as well, because built into the model are all sorts of weights on different language features or different terminologies that's used in medicine, which may not be used in education and vice versa. So it's really important that we don't treat these things as magic. They're not magic. They're simply statistical models, and the basis is the training data. If the training data look like the inference data, then you're in business. If it doesn't, then potentially you're not. So that didn't answer your question, but I think it's important sort of just to think that these things are not magic, and we've got to sort of critique them as we would critique any other statistical model.
It's beautiful.
So
You did use the word weights, but I'll pass the response. I think that was a very good explanation. It is interesting because you mentioned this thing around essentially generalizability of the model, isn't it? So
it is.
Depending, of course, on the model, the training, and then I think, as Alex mentioned, particularly the validation and evaluation is critical. Like we can't deploy a model that's just been trained on, say, medical text, and then without any evaluation expect that it would necessarily be accurate across the whole of science.
No, and we probably should expect that it wouldn't be. Because just like you wouldn't take an evaluation of one drug to mean that every drug will work just the same. We've got to think about.
Yeah. So I think for people who are wondering about these models, like I think one of the things to look at really is like what were they trained on, and particularly what were they validated and evaluated on, and is that the right evaluation for the work that I might be doing with the model?
Yeah, exactly.
So maybe let's just go into. No, I'm going to move on.
I want to answer your question. Okay.
It's fine. I think that's enough detail. So, do you want to just give a bit on? I imagine people on the webinar have heard these terms. So, ChatGPT, obviously, GPT, maybe the term large language model. Do you want to just describe briefly what are large language models? What is GPT? What's the difference between GPT and ChatGPT?
All right, I'll have a go. As you might imagine from the words for a start, a language model is a model of language, and it's a statistical representation of the relationships between words which appear together in text. The reason that it works so well, and I'm sure most of the people on the call have tried it out and are impressed by its results, is that it's built on an awful lot of data. It's built on sort of almost an unimaginable amount of data. We couldn't really sort of, it's far more text than we've ever read and will ever read. So its power comes from the scale of its training. So that's the first thing. So the GPT bit is generative pre-trained transformers. So that's a bit of
technical.
I'm not even going to go into the way transformers work, but transformers have been around for a while. I mean, it's that's kind of old technology, What the bit that's relatively novel about ChatGPT is the generative bit. And so what OpenAI have done really well is to take a language model, a large language model, which many other organizations have built and deployed. But what they've done is they've made it generative. And what that indicates is that it can then generate text, as no doubt you've all seen. And the way it does that is basically to predict what the next most likely word is that would come following a prompt. So the prompt is absolutely key. And we've talked about training and the importance of training before. That's absolutely the same for thinking about a large language model. OpenAI is not being particularly open in many respects about how that model has been trained and what the data are that it's been trained on. We can make some guesses. But we don't know exactly. But it's been trained on an awful lot of data. But also absolutely key in using it is the prompt. And so that you do have control over. And so essentially the way it works is to take your prompt and then to predict what's most likely to come after that. It's slightly complicated, and actually it doesn't always use the top probabilities. Some of the evaluation work they've done suggests that that's not the way to do it. But there's an awful lot of work that goes on sort of before and after, if you like, before and after the language model. And what they've been particularly successful at doing is the pre-work before the language model is activated, as it were, in terms of translating your prompt, your question, whatever it is, into something which activates the right part of that model in order to generate the outputs. So we don't know completely what they've done, and we don't know completely what other training data they've used. But what the really interesting thing that they've done, and the reason that it scared some of the other competitors in the field, is that they've taken something which was tended to be used in the academic field and tended to be more R&D than product, and they've turned it into a product. And someone said, all they've done is to take a large language model, of which there are many, and they've turned it into a product, and now suddenly everyone's using it, as though that was an easy thing to do. And I think that's part of the story that is ignored here, that actually turning something like that into a product is not an easy thing to do, and that's part of their achievement.
Yeah, and then again, just to clarify, when we're talking about the models here and the models that we're developing, we're using the underlying technology, not the generative or chat component.
Certainly what Alex was describing was using what's called the embeddings, which are statistical representations of text, essentially. And yes, so that's not using the generative component at all. That's actually using the language model. And there are many different language models. And one of the interesting points for R&D will be when you strip away this, like the stuff around the model, how much difference does actually your selection and choice of model make?
And of course, some of them there are many models, as you said, and some are open access.
Yeah.
So
very good open access models.
Yeah. So one of the common questions we got before the webinar was, so is AI going to do systematic review? Will they remove the need for humans to be doing systematic review?
Well, not on the current sort of set of technology, no. But who can tell in the future? What I think we can see is that some of the more tedious human tasks can be either replaced or can be enhanced or can be assisted by the use of some of these technologies, which is certainly where we are at the moment. I mean, you can say in 50 years' time, of course, the machines will be able to do it, and maybe, who knows? I don't. But with what we've got at the moment, they can't currently do systematic reviews. They won't be doing systematic reviews next year. But actually, what we are able to do is to make the process more efficient and hopefully remove some of the less exciting parts of the review process, like the screening of thousands of irrelevant records.
Speaking of which, we did have another kind of more feature or task specific question. So I might put this to you, Alex. One of the question was, what is the potential for human screening to cease after a certain threshold of likely relevance is reached?
I think it's definitely possible and will be possible in the future. I think similar to the discussion before, I think the role of the manual screener or people manually doing tasks in the screening or systematic review process is just going to change to essentially support and work alongside models to get to the outcome. So I see that, yeah, some of these tasks that are relatively like decision based of making a decision on clear instructions could definitely be supported by the model. I don't see in the short term the models taking away the entire human element from these stages. I think it will just potentially change how manual screeners or research teams are being involved in those processes. And I think there'll be a lot of kind of working alongside each other in terms of models will be there to support the manual screeners. But I don't see, at least in the short term, the manual screeners completely ceasing. But there will be efficiency gains in there where the model will be able to do things. It will be able to take tasks off them, especially at that kind of later end of the screening processes. And I know there's been a lot of work in that space at the moment, or exploration in that space at the moment.
And again, just to extend that, so these are, I think, what's sometimes called stopping rules. So the kind of holy grail that not only will you have technology that helps you rank or sort citations by relevance, but then have some form of technology that can confidently predict that the remaining citations do not include any true includes. And so again, James, here, I think there's a good example where there are many different approaches to this question, aren't there? So, you know, use of large language models is one approach, but then there are alternatives. And I know, you know, various people have been developing candidate stopping rules for some time. And I think you're also evaluating a number of those at the moment. Is that right?
Yeah, actually, by coincidence, the meeting I'm going to after this is on stopping rules. There's a group of us who have sort of been gathering systematic review screening data together and have put together a code base which we've now got to a sort of a state of tidiness that is sort of shareable. So the plan is that we'll create an evaluation framework, and then we'll open source, we'll put the source up on GitHub so that people can run their own for their own domain. But yeah, there are a half a dozen at least ways of trying to predict how many relevant studies there are during the screening process. It's very difficult to do because by using the system, the ranking system, you are biasing the data that you've seen, and so you can't take that as a representative sample of what is left to come. So they're essentially trying to sort of identify that moment where, you know, the curve sometimes sort of goes up quite quickly and then sort of flattens off. We're trying to find that moment where it flattens off. And it's very tricky, and what we're seeing at the moment is for relatively homogeneous, well-focused reviews, preferably those with lots of jargon in the intervention or the population, that works rather well. And basically the ones where the active learning, the ranking works well, the stopping rules tend to work quite well as well. And so you've got the two going together. But the other answer on this is around the use of the language models, and that there it's really interesting because what we've been talking about up until now has been mostly supervised machine learning, where you've got training data, you train a model, and then you use that model to predict on unseen data. And both the ranking algorithm and the RCT classifier basically do that. With using the large language models, there's this thing called zero-shot learning or few-shot learning, which some of you might have heard. And essentially the novelty there is that you don't need lots and lots of training data. Essentially, because you've got this language model that's built off millions and millions of documents already, that the training data is, the training's basically been done. What you're able to do is say, this is what my review's about. Is this paper relevant or not? And the reason it's called zero-shot learning is you can sort of say, this is my review, this is my paper, is it relevant? There's no training there whatsoever. Or you can say, here's a couple of examples of what I'm looking for, which gives you the few shots part of the learning. And then you get your response from the model. And there, you don't need to think about stopping rules so much. What you need to think about, which there's millions of tweets I'm sure about already, which is the prompt and the prompt engineering. And the challenge there is being able to create a type of prompt which generalizes across reviews. So we can all sit there and sort of create a bespoke prompt which works for sort of historic reviews and recalls the right records and excludes most of the wrong ones. But the problem is, how do you generalize the creation of those rules to reviews where you don't actually have the data there to check? So that's ongoing work. But there was a question, I think, that was sort of saying, well, you screen everything anyway, so all of this is doing is sort of bringing the process of finding the records earlier in the process, but you still look at everything. And I think there's this difference between thinking, well, okay, so bringing them earlier in the process is useful, finding all the relevant ones at the beginning is handy. But then also what we'd like to be able to do is say, actually, we don't want to look at all of the records ourselves if they're not relevant. And there you're then saying, okay, so there is the machine that's basically making the decision that these records are not relevant. And whether you're using a language model to do that or you're using a stopping rule within a ranking algorithm, you're basically saying, I'm going to trust the machine at this point that it's right, and we're not going to look at all the records.
Yeah.
And that seems like a big jump. And I you want to have the right level of caution about it, but I don't think that it's necessarily such a big conceptual leap as sometimes it seems, because those who've and probably there's everybody who's been involved in doing systematic reviews knows that there's a whole load of iteration at the beginning of the review where you're setting your Boolean, the terms that you use in your Boolean search, and choices there will vary the number of records that come through and the sensitivity and the precision of what you of what you retrieve. And so the fact that you've retrieved everything and then don't look at everything seems to be a bigger leap than not retrieving them in the first place. And that's I'm not sure that there is such a difference to say, well, actually that term there is relevant, but it's retrieving a whole load of noise as well as relevant stuff. We're not going to use it because it's giving us too much to screen. I don't think there's so much difference between saying we're not going to use that search term and there is to using some kind of algorithm which then eliminates potentially, or risks eliminating irrelevant records.
So I remember, when we many years ago, when we were starting a lot of this work, you and I think Anna Nollstor spent a lot of time working with information specialists, particularly in the Cochrane community, but beyond, kind of talking about the role that these models might have, particularly in search. And at that time, there was a lot of anxiety about the roles that information specialists might play in an era of machine learning. So what's your just current kind of summary of how you see this playing out now in particularly exactly in search? Like, how do you think this is now going to develop in the world that librarians and others inhabit in information retrieval as information specialists?
I think the information specialists are just as critical as they have ever been. We need people who are concerned with knowledge and the curation of knowledge, and we need people who will be critical about the impact of particular decisions, whether they be automation or not, on what is retrieved. So they're totally critical. I think probably what is important is that all of our roles change over time, and I think in that field it's useful, obviously, to stay up to date with the new technologies as they come through. Yeah, and you know, I say to anybody who's sort of going into research now, that it's probably quite useful to be, you know, to be able to at least read, if not do some coding and scripting in Python/R, because I think that's just a standard research skill that people are going to increasingly need. So you know, it's not everyone's cup of tea, but it's Python isn't rocket science.
So you can imagine kind of ongoing evolution in the role of information specialists, but you know that role will continue to be very important.
Absolutely, yeah.
Alex, I'm going to throw you a live question, which is, would we be able to soon use AI as a second author for screening?
I think so. I think so. With the models, I do believe that the performance of them are getting very close to the performance of a manual screener. And I think at that point, and as it gets even better than a manual person doing the screening, it definitely warrants the question of whether or not these models can actually perform that second screener approach. And I guess the thing we know here is manual screeners aren't perfect. We do have conflict resolution or a third screener going through to check when things don't line up, which suggests that, yeah, people aren't always perfect. And yeah, if models can be at that same level or better, then it should be considered of whether these models can perform that action and actually make reviews even better than the manual screeners performing the role. So I think, yeah, absolutely, it's definitely quickly approaching that point of being able to potentially use models to do that.
Another one hot off the press. So just again for you, Alex, so guidelines about how to address the records that are identified by the machine as non-relevant or irrelevant. You know, what are, or I guess will be, the best practices? Is it to have the ability for the review team to quickly review a subset of those articles to confirm the algorithm has accurately identified articles for exclusion? What would your comments be on that?
And I might even start this off in saying that this is stuff that we want to definitely work very closely with our community to understand what people would feel most comfortable about. In terms of our current thoughts and approach, and what we've heard from the community already, is that, yeah, double checking and the ability to go through that list of studies that have been marked as not relevant, but also override decisions that are made or revert the model's decisions, so it can kind of go back into a manual screening approach, is really important. And I think that's something that we're definitely taking on board in terms of features that we're looking at, is making sure, yeah, double checking is possible. People can see what the model is making judgments on, but override it and also refine things if they need to as well.
Great. I'm going to ask some questions now about ethics. So maybe James, I'll start with you. So just as a broad question, what do you think are the key ethical considerations we should consider when employing AI technologies to assist in conducting systematic reviews?
Okay, well, it does depend on the technology. So for the technologies currently deployed, we're talking about the use of training data or the use of algorithms which are kind of all within the control and have been generated by the people doing the building of the algorithms. The use of language models is different because they have been trained on vast amounts of, to us at the moment, unknown text. We can guess quite a lot of some of the text, but we don't know all of it in detail. But we do know that it's been sort of harvested off the internet at scale. And we know that not all the content on the internet is reliable, let's say, and certainly not unbiased. And so certainly we'd have ethical difficulties with some of what's said on some of the data which ends up in the language models. So the companies that have been producing them have worked quite hard over the last few years to try and reduce obviously objectionable output coming out of the models. And I think that what we've got to bear in mind here is that that doesn't mean that the models themselves have changed in a fundamental way. They've reduced some of the really obviously bad stuff, which when in the early days of these models coming out, it was very you could just put a couple of keywords in and see what horrendous stuff got produced. That's not so much the case now, but you can still see biases that are encoded deep within the models in places, in terms of sort of particular roles and genders and that kind of thing. It's very easy to uncover clear biases. So there's a question of ethics in terms of whether or not you should support an ecosystem which is more interested in making lots of money than eliminating some of these biases from its models, which clearly there's an economic imperative there. But then there's also the question of the impact of using biased models within a systematic review process. Some of the time you can argue probably quite strongly that it won't actually affect the review process, but for some reviews, some of these biases may well be more important than others. So at the moment, we kind of don't know. And then the last part of the ethics on this is, as well as sort of bias and concern about the way that biases are encoded within the models, we've then got the way in which a whole load of additional training data has been generated, and we don't really know all that much about that, only that there is this big industry, often in lower middle income countries, where people sit there hour after hour labeling training data, whether it's for OpenAI, whether it's for autonomous driving vehicles and that kind of thing. But those on one level, it's that's an economic argument and it's providing employment, etc. It's a little bit almost like sort of like Wild West. We don't really know what regulations are in place to protect people who are engaged in those kinds of employment.
Alex, what are your thoughts about how this plays out in the way that then the models are deployed within a product like Covidence? And the kind of work that you're doing, looking at the opportunities for this to be then in production, used by people doing systematic reviews. What do you think of the risks and kind of approach to mitigating that?
Yeah, I think we need to be very careful, and I think it's across the board, not just even in the industry, of how we're using these models and what we're asking them to do. I know from our perspective, we are very cautious about using models for particular tasks, and we're looking at individual tasks in terms of what it can do and whether or not it's appropriate to use this, and whether or not there's a risk of bias coming in or things that wouldn't be acceptable happening from the model. So yeah, we're very cautious in terms of what we actually use this for, and make sure the intended purpose is appropriate. We're also doing validation across the boards, which will hopefully, before we move any of these models through to something that is in production and being used widespread, is that if we do see this coming out in our early validation data or any of our validation data, it's a point for us to dive in and really understand whether or not it is an appropriate use to use, and that's something that we've been considering through our validation.
Great. I know we don't have a lot more time, but James, I just wanted to get in a little bit around adoption. So we've had a number of questions really about Prisma. So how should people report this in the against their Prisma? And I think a number of questions have kind of highlighted really how they can ensure that peer reviewers are reassured that they are using in using these models, they are following appropriate systematic review methods. So as I have to mention this, as a co-editor of the current version of the Cochrane Handbook, and one of the world's leading machine learning researchers in systematic review. Who could be better placed to answer this question?
Well, I think the first thing to do is to read and follow Prisma, the 2020 version. We spend a lot of time trying to gaze into crystal balls and anticipate what guidance would be needed here. So the current Prisma does have guidance on the use of AI, automation, machine learning in reviews. The fundamentals is obviously report what you did, report what tool it was, what version of what tool it was, etc. But then also, like any other use of, any other method in your review, justify why it was appropriate to do. So RCT classify, there's a paper on that, justify that. The way in which you used ranking or prioritized screening, there are many papers on that. If you did implement a stopping rule, there are papers on that. Okay, so you cite it, but you also have to say why you think it was appropriate to do in your review, and that's sometimes where it's slightly more difficult, because some of these evaluations are done on either larger reviews or in a different domain to yours, and so we're then thinking about the generalizability question again. So if you find it's actually quite hard to find an evaluation which justifies the use of AI in a particular review, then maybe actually what that should be telling us is it's actually quite hard to justify the use of AI in this particular review, in which case we need to do some more R&D.
Yeah, absolutely. So obviously what's important here are really the validation and evaluation studies, so that we can all have confidence that these models are performing as described by the developers, but also I think importantly so that it can give appropriate information not only to the users of the models, but also of course then to peer and editorial review, and then of course ultimately the readers of the review, that people are actually consuming that review.
Yeah. Can I answer a question that I thought was really interesting one from 1040 on this?
Yeah.
It was around the remove.
Okay, please go ahead.
No, just because it seems a shame not to mention this, because I think it's really an insightful question.
Yeah, I think
in terms of the removal of the human aspect of screening, does it remove the opportunity for incidental insights? I think that's really interesting, because I think possibly it does. It reminds me a little bit of back in the day where we actually went into the library and we looked along the bookshelves to take the books off, if you can remember ever doing that. And everything was catalogued, and it depends on which system you were using. But the number of times I went to the library to find one book and I came back with half a dozen, because they were all, you go to one area and they've been nicely catalogued. So, if you're interested in this, you might be interested in that and that and that. And so suddenly, I end up with all of those. And it's a little bit like that when I'm screening. I don't like screening for hour after hour, I must admit, but there's something actually quite useful about doing screening, especially in the early part of the, when you're using the prioritization, and it gives you the relevant ones, and it gives you the adjacent to relevance as well. And it really gives me quite a nice insight into the location of my review in relation to other adjacent literatures. And I'd be sad to lose that completely. I wouldn't be sad to lose having to screen 20,000 records, but that I think there is something that if we think, oh well, all of this can be automated, actually we do lose some of the insights that we get from having to go through some of these processes.
No, I completely agree, and this is where I think so much of the opportunity here, and I think we all agree it's a huge opportunity. We've been working in machine learning for a long time now, and when you kind of take a step back, wouldn't you agree? Like all the work that we've been doing, you would say as a field, unfortunately, machine learning is somewhat under-delivered for systematic review over the last 10, 15 years. When you look at the actual number and impact of the models that are actually deployed in production at the moment, it's not an overflow. And so I think we are at an extremely exciting time. I think we are going to see this accelerate. But in terms of how we use it, I think so much that is going to come down to really good design. It's essentially talking about human-computer interaction. What are the roles that machines can play? What's important that humans still do? And then, of course, how do people interact with those systems in the most efficient and appropriate and ultimately satisfying way? So this is why it's very much a kind of joint effort, I think, between obviously people who, the large companies that are developing these incredible models, but of course the people who understand domains very deeply, like yourself, James, developing other models and fine-tuning, etc. And I would say, of course, people like Alex, who are actually, thinking very carefully about the ways we actually deploy these in our products. Great conversation. Again, I have to say, unfortunately, there have been so many great questions posted in the live chat. We were only able to capture a very small percentage of those. So thank you for everyone who submitted questions, and I'm sorry we weren't able to get to them all, but hopefully this discussion has been helpful. And I'll just hand back to Julie to close.
Thanks, Julian. I just want to thank our panelists for an amazing and insightful discussion on the role of AI in systematic reviews. I think this gives us a lot to go away and think about as systematic reviewers. Thank you to everyone who's attended the webinar and to everyone who's submitted questions. Engagement is really important to us. As always, if you have any follow-up questions, you can send them to us at support@cofidence.org, and we'll pass those on to the relevant people. And we hope that you all have a good morning, afternoon, or evening, wherever you are in the world. Thank you so much for your time and for attending.
Thanks, everyone.
Thank you.